Howdy, howdy. This is Mr. Potter. In our last discussion of mathematics for a while, we're going to be talking about the math class. Now, the math class is a class that has a whole bunch of static methods that we can use to perform mathematics on different values, different variables, different expressions. And so I want to start by talking about rounding. And so I'm going to do three different statements here. System.out.println, and I'm going to do math.round 4.5. I'm going to take this line of code and I'm going to copy it, but instead of round, I'm going to replace it once with ceil, and I'm going to replace it with floor. So if I run this, I want to talk about what's happening here. The thing is, the math class has rounding, but there are different types of rounding based on different situations. So, for example, if I had enough money for 4.5 people to go on a airplane ride, then I really can only afford for 4 people to go on that airplane ride. That 0.5 is really kind of useless. And even if I had enough money for 4.9 people to go on an airplane ride, that's still a situation where I would have to round down. Similarly, if I had a job that took 4.5 people to complete, I really need 5 people to complete the job. Even if I had a job that only required 4.1 people to complete, I'm still going to need 5 people to complete that job. So there are situations where instead of doing our traditional rounding, in other words, rounding if it's 0.5 or higher, rounding if it's between 0 and below 0.5, I may need to automatically round up no matter what, or I may need to automatically round down no matter what. And so the math class allows us to take care of that. We can do math.round whenever we want to do our traditional rounding, like rounding to the nearest penny or rounding to the nearest what have you. But whenever I need to force myself to round up no matter what, I can use math.ceil. And whenever I need to force myself to round down no matter what, I can do math.floor. So I've got these different techniques of rounding. Another thing that's very interesting to note is that math.round is actually going to give me an integer result. I get 5. I don't get 5.0. But when I do ceil and floor, I end up with 5.0 and 4.0 respectively. In other words, math.round is going to return an int, but math.ceil and math.floor are going to return doubles. So it's important to make that distinction. Another distinction that's actually very, very important for us to make is if I was to do the same thing, but if I was to do this with negative 2.5, and I was to do the same thing, doing ceil and floor, the results are something that you may not expect. So ceiling and floor. So if I run this, notice the results that I get are negative 2, negative 2.0, and negative 3.0. So in other words, ceiling is rounding up. But if I'm looking at a thermometer, negative 2 degrees and negative 3 degrees, negative 2 degrees is warmer than negative 3 degrees. So rounding up means that I round up to negative 2. And when I do the floor, since negative 3 is the colder temperature, negative 3 is where I'm going to be rounding down to. So it's just something you need to be aware of when we're rounding involving negative numbers, that sometimes that behavior may not be our typical behavior. So just be aware of that. So we have round, ceiling, and floor, which allows us to round based on our needs. Another important part of the math class is to be able to come up with random numbers. So we have math.random, and what math.random does is this generates a random number between 0 less than or equal to x less than 1. In other words, some decimal between 0 and 1. And so if I run this, notice that I get this 0.74760959. If I run it again, I'm going to get a different number. I get 0.9588674. And if I run it the third time, I'm going to get another 0.528. I can get any possible number between 0 and 1. And so this is a very useful term when I want to come up with some type of random value. And we'll talk about the use of random numbers later on in this course. Now, the thing is, because this is giving me a value between 0 and 1, if I want to get a number between, say, 0 and 5, then what I really need to do is I need to take 5 times math.random. And so what that will do is that will force it to be a number between 0 and 5. Notice I've got 2.46. If I run this again, then I've got 4.659. If I run it a third time, then I've got 2.267. So if I want to change the range of the function from 0 to 1 to 0 to some other number, I can do that by multiplying by whatever I want my width to be, my range, my low minus my high minus low. And then if I want to translate that, let's say I don't want to range from 0 to 5, let's say I want to range from 5 to 10. I can do that by adding 5 to the result inside the parentheses here. So now if I do this, I should get numbers between 5 and 10. So here's 6.479. If I run it again, I'm going to see 5.031. If I run it a third time, I'm going to get 8.93. In other words, it's going to take this 0 to 1 window, stretch it out by a factor of 5, so it's now a 0 to 5 window, and then add 5 to it, so instead of being a 0 to 5 window, it's a 5 to 10 window. So this math.random allows me to generate random numbers. Now, one thing to realize is that these are pseudo-random numbers. In other words, they're not truly random numbers. And later on in the course, we'll actually talk about how to make reproducible random numbers. In other words, numbers that are random-ish, but we can actually reproduce them over and over. Because the computer uses a process to get these random numbers. And that process, because it is a step-by-step iterative process, it can be manipulated. So we'll talk a little bit more about true randomness versus pseudo-randomness later in the course. But for right now, math.random is a wonderful tool to get numbers that for all practical purposes, are random enough for our needs. Other things that are important to know is I can do math.square root, and it's math.squirt. So I can take the square root of a number like 729, and it'll tell me that the square root of 729 is 27. Notice that it's giving it to me as a double. The thing is, almost all of these methods are going to return a double. The only method that's not returning a double is math.round. And similarly, I can actually take this and raise any number to any power using math.pow. math.pow actually has two parameters. So I'm going to take my first number, which is 9, and my second number, 3. So what we're actually doing here is we're raising 9 to the third power. And so doing that, 9 times 9 is 81, and 81 times 9 is 729. So I've got math.square root to just take a real quick square root. I've also got math.pow. And if I want to, I can manipulate this a bit. I can do math.pow and raise 9 to the 1/2 power. And remember that raising to the 1/2 power is really taking the square root. So this gives us 3. So I can use math.pow to take a square root, but math.square root is much easier to do so. And one other thing that we have to deal with here is we will often deal with trigonometric values like sine, cosine, and tangent. So I can ask it to find the sine of a particular angle. Let's say pi over 2. So remember in our previous videos, whenever we dealt with constants, our constants tend to be exponential. Tend to be capitalized. So I'm going to take math.pi. Notice this pi is capitalized, divided by 2. And so what this is going to do is it's going to find the sine of pi over 2. Notice my angle has to be in radian measure, and the sine of pi over 2 is the sine of 90 degrees, which is 1. I can do the same thing with tangent or cosine. And I can even work backwards. I can do math.atan and find out where the sine is equal to 1/2. And of course, my sine is going to be equal to 1/2 at 0.523598775 radians. Of course. Here's the thing, though. We don't normally deal with radians. Normally we deal in degrees. So math also has two methods we can use. I can do math.2 degrees, and it'll take a number that's in radian mode and convert it to degrees. So let me type in this 5235987755982982989, and we'll find out that sine is 1/2 at 30 degrees. And again, this reminder, because we're working with doubles, there is going to be a little error in that last decimal place. So you do need to be aware of it. We're going to have to work around that when we start testing for equality. And if you don't remember your radians, there is a 2 radians method. So system.out.println math.to radians. And so I can take this 45 degrees that we're used to and find out that 45 degrees in radian mode is 0.78539. Now these trig values that I was talking about, we have cosine and tangent. And for these arc cosine, arc sine, we have arc cosine and arc tangent. So we have this ability to work backwards and forwards through sine, through cosine, and through tangent. And another thing that's important to note is that we do have this constant, this mathematical constant, math.pow. There is one other constant that we have, and those of y'all are familiar with exponentials and logarithms, you'll notice this constant. So I'm going to take the system.out.println. I'm going to do math.log, and I'm going to take the logarithm of math.e. And E is Euler's number. E is equal to 2.7182818284559 ... One of those transcendental numbers that keeps going on and on forever. Now, what's also important to note is that this is actually the natural log. Even though it's log, this is the natural log. And it helps if I put a semicolon at the end of the statement. And so the natural log of v is 1. If I want to do the common log, or the log base 10, I need to do math.log 10. And inside the parentheses, let's put 10,000. So because I have 4 zeros, this should be 10 to the 4th. And so the log base 10 should be 4. So there's lots of things that we can do mathematically. Basically, anything that we've learned in a geometry and algebra 2 or pre-calculus class, we can do in Java. And the math class is the tool that we use. So once again, this is Mr. Potter. Thank you for watching. Have a great day.